So now we have ourselves the following problem of discriminating between one-tailed and two-tailed tests. The object of a two-tailed test is as follows. The person postulates a value for the mean, and he doesn't care a hoot and a holler whether the observed event appears higher than the mean or lower than the mean. The sign of the deviation y minus eta is of no importance to him whatever. This permits the rare event to happen two ways. And in point of fact, we find ourselves having to divide the 5% probability area equally in both tails of the distribution. And to give you some geometric appreciation of what this means, we see here once again the standardized normal curve with mean 0 and standard deviation equal to 1. And you will notice that the value of z necessary to plug in 2.5% in the tail of the curve, in this case, is 1.96. And so if we were running a two-tailed test of significance as opposed to a one-tailed test of significance, then we would find for our critical value 1.96, and the essential question would be, gee whiz, is z larger than 1.96? Because if it is, I'm going to reject the hypothesis. Whereas if we were doing a one-tailed test of significance, the question would be, is z greater than 1.64? Plus or minus, because the sign's important here. And then if it were larger than 1.64, we would reject the hypothesis unless we'd accept. Okay, let's do a two-tailed test. Let's imagine someone comes up, as they did previously, and declares that eta is equal to 12. Now, this person doesn't care whether or not y comes out above 12 or below 12. The sign of the deviation is not in the least important to him. And so let's do a test of significance under these circumstances. Once again, we find ourselves locating the distribution down here at 12. And once again, we find ourselves evaluating the normal deviate. You know, z is equal to y minus eta divided by sigma. And that comes out equal to what? Well, by golly, that comes out equal to 5/3, 1.67. Now, this is a two-tailed test we're doing. What's the critical value of z? 1.96. What's the observed value of z? 1.67. So our observed value of z is not in the critical tail of the distribution. It's not in the tail of the distribution out beyond 1.96. Hence, the event under a two-tailed test is not a rare event, and I find myself in this situation doing what? Oh, by golly, since it's a two-tailed test I'm running, I'll have to accept the hypothesis that eta is equal to 12. Now, I know that for students taking a course in statistics, this business about one-tailed tests and two-tailed tests is indeed a little awkward, a little difficult, and we expect you to be modestly confused at first. We'll have ample opportunity in the future to explore these nuances again and again. Perhaps I should give you some sort of an example relative to one-tailed and two-tailed tests. A two-tailed test, you don't give a hoot for the sign of the deviation. Someone has a standard production process, and someone proposes an alternative process. And the only thing that we're really worried about under these circumstances is the following. We just wonder whether the alternative process is different from the standard process. And so when we take a single observation on the alternative process, we don't care whether that single observation falls above or below the mean. The essential thing is, how far away is it from the postulated mean? And so the sign of the deviation wouldn't be relevant. And under those circumstances, we would do a two-tailed test of significance, and the critical value of z would be 1.96. Now, what about a one-tailed test of significance? Well, supposing the only reason for modifying the process was to improve the process. The only things we're interested in are positive deviations. You see, the sign of the deviation now becomes relevant. Under such circumstances, when we did a test of significance, since the sign is relevant, we would end up doing a one-tailed test of significance.